one complicated thing in NH2 is defining the range actually. Since this is just a variable, suppose communication range I have provided 500 meters. Okay, so the communication range, it is not directly provided as input in the source code. We have to provide actually in terms of power. Okay, so these 5 lines are actually converting the communication range into power. Means for this particular communication range, how much transmission power is required. And the second thing is what affects the transmission range, the capability of the receiver to receive the data, means to receive any packet, means how much power it can detect. Okay, that thing you should provide. Means okay, so you can understand receiver sensitivity. This is the value that is provided as the receiver sensitivity. These are some fixed values. You can search on internet, you will be finding a table for a particular threshold value. So this particular threshold value is for is provided for a particular range. Okay, but with respect to it, the corresponding transmission power is also provided. Okay, so let us understand these things quickly. Lambda value is there. What is lambda? C by F. What is the frequency range of this band? DSRC band, if you have learned some theory already, 5.9 gigahertz band. So it is written here 5.9 into 10 to the power 9, and the speed of light 3 into 10 to the power 8. Pi value is provided here. This is the formula. These two are the formulas combined. PR by PT formula. What this formula is? 5.118 square into lambda divided by 4 pi r square. Okay, this is the formula. How they derived this formula, I have not tried to learn. Means this is for regular network, maybe for Nakagami propagation model, since they are using. That is for that purpose only. However, if you see their paper, it might be you may see for what purpose it is, but I will suggest you to keep this one as it is. Now formula for PT is actually the sensitivity divided by PR by PT. Okay, so if you are on a copy and pen, you solve this formula, finally you will receive the PR value actually. Sorry, the PT value you will receive. So how much power you have to transmit, that you will be knowing using this formula. Means here you will calculating the transmitted power. So what they have done, whoever has designed this patch, they have made this TCL file very simple, because you have to provide just this value. Suppose you want to change it to 300 meter, then you have to change here only. You don't have to see these things actually. These things are not required for you to see. Okay. However, if you want to change the sensitivity of the receiver, means how much power it can understand, then you can change it. Otherwise, I won't suggest you. Okay. So since we are working on MAC layer, so no need of that obviously. Okay, so up to here, now here PT in milliwatt just multiplied by this PT variable. PT into 1000, we have converted it in milliwatt. Okay, now one more thing I will make it clear to you. This EXPR TCL file is a bit of complicated language. So if you want to do any calculation, this EXPR you have to write. Suppose if you write this one directly, 3 into 10 to the power 8 divided by 5.9 into 10 to the power 9, then it will show an error. So you have to provide EXPR as well. Bracket EXPR, then here bracket close. In between you have to write the equation. whatever you want to solve. Then only it will solve. Similarly here, this is one equation, 4 into pi into r. So it is put into an expression. Again this is fed into this expression. Okay.